flipped classroom video for Maths A2 Unit 3, Basic Partial Fractions. So, if we want to add two rational expressions, then we can add them in the same way as we do for numerical fractions. We'll first look at two linear denominators. So, if we had 1 over x plus 1 plus 3 over 2x plus 5, and we'll have a look at the graphs for these. So there they are, and they're colour-coded. We can see that the 1 over x plus 1 graph has an asymptote at -1, and the reason for that is, have a little think, that's right, because it makes the denominator 0, so off it goes to positive infinity from the right and negative infinity from the left. And then 3 over 2x plus 5 has an asymptote at -2.5. So there's our green asymptote, and there's our red one. Okay, so we need a common denominator. That means we multiply the denominators together, and then we need to multiply the 1 by the 2x plus 5 and the 3 by the x plus 1, in the same way as we would for ordinary fractions. The equivalent symbol that we're using here is important. It's true for all values of x. Remember, the upside down A means for all, and that means it's identical. So it's not an equation, which would mean it would be true for some values of x. It's an equivalence. And there, just to reiterate, is our common denominator. Okay, we then open up those brackets in the numerator. So we've got 2x plus 5 from the 1 times 2x plus 5 and 3x plus 3 from the other bracket. Tidy that up. 2x plus 3x gives us 5x, 5 plus 3 gives us 8, and that is 5x plus 8 over x plus 1 times 2x plus 5. Now, you can, if you like, multiply out the bottom of this fraction. Sometimes that's going to be useful, other times it isn't. It depends on the context. If we have a look at the graph of those two functions added, that's the blue graph, we can see that this function has two asymptotes, which are the original asymptotes, and that's because it's still 0 in the denominator for those two values. And we can see what happens with that. So have a little look at that, and perhaps have a play with that and similar ones on GeoGebra. So, partial fractions. We've looked at adding two fractions together, which is something you have looked at before, but now we're going to look at partial fractions, which are, well, let's see, what are they? Partial fraction decomposition essentially means expressing a complicated rational expression as a simpler one. Why might we want to do this? Well, it can be very useful in all sorts of ways, for computation, so calculating values and so on, for calculus, for differentiating or integrating, and so on. What we've just looked at was showing that we can add rational expressions to get a single function. And what we found was that 1 over x plus 1 plus 3 over 2x plus 5 is the same as, that's what the triple equal sign means, or the equivalent sign, 5x plus 8 over x plus 1 times 2x plus 5. Now, what if instead we'd been given 5x plus 8 over x plus 1 times 2x plus 5, and we wanted to decompose it, so turn it into simpler fractions? In other words, work in the other direction, the opposite direction. So that would be our aim. We would want to turn 5x plus 8 over x plus 1 times 2x plus 5 into a fraction with a denominator of x plus 1, plus, could be minus of course, but that would just mean b was negative, but anyway, plus another fraction with a denominator of 2x plus 5. And the denominators are linear, and that is why we know in this situation that the numerators will be numbers. Considering those sort of issues with these will build up as we go, so we won't dwell on that for now. So we've got this situation. Now if we multiply the whole thing through by x plus 1, 2x plus 5, then on the left hand side both those brackets on the bottom of this fraction will cancel, and we will be left with 5x plus 8. On the right hand side, we can see why we're doing this, because we want to get rid of all the fractions, and the x plus 1s will cancel for the first one and the 2x plus 5s for the second one, and that leaves us with 5x plus 8 is the same as a times 2x plus 5 plus b times x plus 1. And because this is an equivalence, not an equation, the coefficients for each power of x must be the same on both sides. So if we look at the coefficients for x, then on the left hand side we've got 5. On the right hand side we're going to have 2ax from the first bracket and bx from the second, so altogether we have 2a plus b lots of x. And that's our first equation. We've got two unknowns, a and b, so we need two equations. So for the constant, we've got 8 on the left hand side, and then from the first bracket we get 5a, and from the second bracket we get b, so that will be 5a plus b. That's our second equation. And then the simplest way of dealing with this is to subtract. So we subtract 1 from 2, and that gives us 3 equals 3a, because the b's subtract away, and that means a is 1, obviously by dividing by 3. That's a bit of overkill on the right hand side there, and we can then replace a in equation 1 by this value that we've found that it is, and we get b is 3 by subtracting 2. So that means we've found that 5x plus 8 over x plus 1 times 2x plus 5 is equal to, or is the same as, I should be more clear, 1 over x plus 1 plus 3 over 2x plus 5. And we knew that already, of course, but had we not known that, that's how we could have found that out. Now, another way to tackle this is using values of x to eliminate a and b. If we put x equals minus 1 into this equation, then what that will achieve is it'll make x plus 1 equal to 0, so that will get rid of the b, because that will be b times 0. So if we put minus 1 in, we get 5 times minus 1 plus 8 on the left hand side. On the right hand side we've got a times 2 times minus 1 plus the 5. The second bracket, the b times x plus 1, as I've just said, will disappear, and so we can just tidy up. That gives us 3 equals a times 3, and therefore of course a is 1. For the first bracket, to get rid of that, we'd have to have x equals minus 5 over 2, and that obviously will get rid of that bracket, it'll make it 0. So then when we substitute that in, we get 5 times minus 5 over 2 plus 8 is equal to b times minus 5 over 2 plus 1. Tidy that up. On the left hand side, 5 times minus 5 over 2 is 25 over minus 25 over 2. 8 is 16 over 2, so we've got minus 25 plus 16, which is minus 9. And then on the right hand side, we've got minus 5 over 2 plus 1 is minus 3 over 2. 2's cancel. Divide through by 3. Minus 3 even, and we get b equals 3. And of course we get the same result as we got before. So that's two different methods for tackling these situations. Okay, we've had a look at two linear terms in the denominator, and now we're going to have a look at 3. For example, we could have 7x squared plus 24x plus 17 over x minus 1 times x plus 2 times x plus 3, and we're going to start in the same way as before. It's basically the same method. We're going to suppose that this can be decomposed into 3 fractions, each one having one of the brackets from the denominator as their denominator. So we have that our original function will be equivalent to a over x minus 1 plus b over x plus 2 plus c over x plus 3. Now if we multiply through by the denominator, then we end up with 7x squared plus 24x plus 17 is the same as a times x plus 2 x plus 3. Now the reason for that is of course the x minus 1 cancels. Now for the second fraction, b over x plus 2, when we times that through, the x plus 2 cancels away, leaving us x minus 1, x plus 3. And for the third one, the x plus 3 cancels, leaving us with c times x minus 1, x plus 2. And we could now proceed by comparing coefficients of powers of x. So if we have a look at x squared, we can see that we have an ax squared from the first part, a bx squared from the second bit, a cx squared from the third bit. So that would mean that we have 7 on the left hand side, 7x squared, and that would have to be equal to a plus b plus c. And using x and the constant term as well, this would give us 3 equations with the 3 unknowns a, b and c, and that would be easy enough to solve. What I'm going to say though is have a try at that for yourself. What we're going to do is the substitution method, which works quite well here. We can eliminate 2 terms at a time using particular values. So we could start with x equals minus 3. Now that's going to get rid of the a term and the b term, because both of those have got the bracket x plus 3. When we put minus 3 into those, they become 0. So we're just left with our left hand side with the minus 3 substituted in, and the c part of the right hand side. So what do we get? We have 7 times minus 3 squared plus 24 times minus 3 plus 17. That must be equal to c times minus 3 take away 1 times minus 3 plus 2. So all we've done is subbed in minus 3 for x, and we tidy that up, and we get 8 equals c times minus 4 times minus 1, and therefore c is 2. You can probably work out what the other 2 numbers we're going to use are. First we're going to use minus 2 because that makes the x plus 2 bracket 0, so that will get rid of our a and our c. And we have this, which is 7 times minus 2 squared plus 24 times minus 2 plus 17, and that equals b. Obviously the a term and the c term are 0. So it's b times minus 2 take away 1 times minus 2 plus 3. Again, we tidy that up, so we have minus 3 equals b times minus 3 times 1, and that means b is 1. So the final one we need to do is we need to put a 1 into the other bracket, so x equals 1. That will get rid of the b times x minus 1 x plus 3 and the c times x minus 1 x plus 2. And will leave us with just the a term. So we have 7. Don't need to bother writing the 1 squared here. You could if you wished, but I'm not going to. 7 plus 24 plus 17 is a times 1 plus 2 times 1 plus 3. And that means 48 equals a times 3 times 4, which means that a equals 4. So that means that our partial fractions for this 7x squared plus 24x plus 17 over x minus 1 times x plus 2 times x plus 3 is 4 over x minus 1 plus 1 over x plus 2 plus 2 over x plus 3.